Hello, this is Ms. DB, and in this lesson I'm going to show you how to do the Chapter 4, Section 4 Sketchpad assignment from the Algebra 1.5 class. So first thing, when you open the Sketchpad assignment that's attached, you have to make sure that you see these tabs down at the bottom. If you don't see the tabs, then what you need to do is maximize your window. Like right now it's not maximized. I need to push on this little window to maximize it, and you might even have to do this as well. I didn't want to do it for this because my video isn't that wide of a screen, but that's the idea. Okay, so now that you see all the problems, there's 12 problems to do. You've got to be able to find them all. So if you just click on, actually there's not even, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems to do. These are from the book, but it's easier to graph in Sketchpad in the online world and then attach it. So here's what it says. Graph the function for the given domain. Number 1, 3x minus y equals 1. Step 1, solve this for y first. So you can solve for y on your own paper, or you can use the Sketchpad tools to write. Like I'm going to solve this for y using the pen tool. So if 3x minus y equals 1, I already solved this for y right here, but if you had to solve this for y, you could add y to both sides, and then you would have 3x equals y plus 1, and then you would have to subtract 1 from both sides. So y would equal 3x minus 1. Now I already did do that because look at it's right here for you on the table. Okay, then you're going to take your values of the domain, which is -3, -1, 0, and 4. This time the domain is given for you, so you'll put those in for x here, and then you'll replace x with each of those numbers one at a time and solve and see what you get. So I did do the first one. 3 times -3 is -9. -9 minus 1 is -10. So the first point is -3, -10. Now you can graph that right away if you want, but let's finish our table first. Then I'm going to plug in -1. So 3 times -1 is -3. -3 minus 1 is -4. So I would have the point -1, comma, -4. Now, I have a little pen on my laptop that I can write easier with, but if you don't, you can use the A tool to type. This is a text box already. You can see it's kind of on top of where I wrote. So let's do the next one just by typing. 3 times 0 is 0. 0 minus 1 is -1. So my point over here would be the x was 0 and the y is -1. So you can type your work on here too. And now the next one, I didn't put all the work in. If I'm going to solve when it's 4, I'm going to take 3 times x, but now x is 4, so that's 3 times 4, and then -1. And you can see I've got spaces in here to make it look like it was a table all nicely lined up, and then I messed it up, so fix it however you want. And then 3 times 4 is 12, and 12 minus 1 is 11. So y will be 11 when x is 4. So that's the point for 11. Okay, now it's time to graph all of these points. I had written that one on the screen. So here's the best way to graph points in Sketchpad. Go to Graph, go to Plot Points, and now you're going to enter in the coordinates of your point. So my first point is -3, 10. So I have to change this to -3, and I have to change the y value to 10. And you can do that on your keyboard and hit Plot. And that point will show up. It's down here so you can't see it. See, there's the point. And now I'm going to graph some more. So my next point, actually, did I forget the negative on that one? Because there's a point up here that's the wrong point. It's supposed to be 3, -10, but that is down there, so I might have forgot the negative the last time around here. And then the next one is -1 and -4. That one you can see right there. And then the next one is 0, -1. And then the last one I have to do is 4, 11. Okay, now they're all there. See them? There's 4 points. That one's smaller, but that's okay. They're all there. Now, I would connect these points with a line or a line segment if the domain was like all real numbers or from -3 to 4. But it's only specific discrete values. This is the discrete function, and I want to leave it with discrete points. So I don't do anything else with this. That's what this is saying right here. Don't connect the points for number 1. Let's look at number 3. Number 3 also gives you the value of a domain as specific discrete points. So we're not going to connect this one either. We're going to do the exact same thing for number 3. It's number 3. Let's look at number 5 and 6. Number 5, this time the domain is all real numbers. So this time, the first thing to do is solve for y or solve for f of x. Either thing is the same. We don't have to do that in this one because it's already f of x equals 6x plus 4. So now I'm going to plug in my values right here. I'm going to use my pen tool again to do this. And the first one again is already done. We plugged in at, now I got to pick my own values for the domain, but I already put some on the table for you. But it just says the domain is all real numbers, so all you'd have to pick for your domain is any real numbers. So I already did -2 and got -2, -8. That's 1 point. At -1, I'd have 6 times -1. That's -6 plus 4 would be -2. So when x is -1, y will be -2. Then when x is 0, I'd have 6 times 0, that's 0. 0 plus 4 is 4. So my next value will be x is 0, y is 4. That's going to be a point. And then my last point is when at 1, when x is 1. So 6 times 1 is 6, plus 4 is 10. So I get y is equal to 10. So at x equals 1, y equals 10. And then remember how to graph these. So you go to graph plot points. And my first point is -8. Oh, sorry, -2. -2, -8. I always have to put the x first. And then the next point is -1, -2. And then the next point is 0, 4. And then the last point I need to graph is 1, 10. Now this time, my points, they should all lie in a line. They always will if you're graphing a linear function. I'm going to connect these points this time. And because my domain is all real numbers, I'm not going to connect it with a line segment. I'm going to hold this button down, and I'm going to pick the one with the line on both ends, because that's a line, and that would include the domain of all real numbers. So when you do it, it's going to look like it's swinging all over. Just click one of the points that we had and drag it to another point that you had. And then just scroll down and look. Yep, all the points that I had graphed are on that line. This is a linear function, so they should all be on that line. So this was number 5. Now you might want to write number 5 next to it. You can use the A thing and make a text box and put that this is number 5. Maybe I want to write that this is f of x equals 6x plus 4. You can also check this a really nice way. You can go to Graph, Plot New Function, and the part that's after the f of x or after the y, after the equal sign, 6x plus 4, type that in, 6x plus 4. And look up here. It should look exactly the same. f of x equals 6x plus 4, f of x equals 6x plus 4. Hit OK, and that line just graphed right on top of the line that I just had. So Sketchpad will graph lines directly. You don't have to plot points, but this section is on plotting points. So you're going to plot the points, and then you can check it by graphing the equation. So this was number 5, and then you're going to do number 6. So this table isn't here for number 6. You get to make your own table. And again, if you want to make the table on your own paper and just put the points on here, that's fine. You get to pick whatever values of x you want, and then you'll use those values to solve for y. Now, when I look at the function 1/2 times x, I'm going to pick even numbers. I'll always like 0 because half of 0 is 0, plus 4 is 4. That one's easy to find. For the rest of them, though, I'm going to pick positive even numbers to make it easy on myself, because half of 2 is 1, and 1 plus 4 is 5. And then I'm going to pick like 4, and maybe I'll pick one more point of 6. So you take half of that number, half of 4, half of your x value, and then add 4 to it. And then you'll plot your points, and you'll connect them with a line, just like we just did. Let's just look ahead and see if there's anything different. Number 7, graph the function, assume the domain is all real numbers, graph 7 and 8. Okay, so 7 is no different. except that you have to solve for y first. So you'll subtract x from both sides and get y equals negative x. So when you pick your values for x, you have to take the opposite of them to get the y values. It's going to end up looking like a nice diagonal line going right through here. Like when x is 1, y will be negative 1. When x is 2, y will be negative 2. Now 8 is going to look different. 8 is the absolute value of x minus 4. Let's look at this one. Let's pick some values of x. Now again, you get to pick whatever you want. So 0 is always nice. The absolute value of 0 is 0. 0 minus 4 is negative 4. There's our first point. Now I want to pick some negatives and some positives to see what will happen. When I have x is equal to negative 1, the absolute value of negative 1 is positive 1. 1 minus 4 is negative 3. And then I'll put in 1. 1 minus 4 is also 3. Because the absolute value of 1 is 1, 1 minus 4 is 3. Negative 3, sorry. 1 minus 4 is negative 3. So when I plot these points, which I'll do the way I'm supposed to, but real quick, I'd have 0, negative 4, then I'd have negative 1, negative 3, and I'd have 1, negative 3. It's going to make this kind of a V shape, which is what all the absolute value functions look like. And you can even graph it and see that. In Sketchpad, to get to the absolute value function, you have to go to Functions and pick ABS, stands for absolute value of x. See? Absolute value of x. And then minus 4. You always want this part up here to look like this part over here. And see that? It looks pretty much like I had started to graph, but theirs is better than mine. So continue working on this assignment. If you have any questions, let me know. And remember that discrete functions will just be a set of points. Continuous functions, where the domain is all real numbers, will be a line. All right, thank you very much.